And first off, we're going to say the inverse of a function is denoted by f negative 1 x. And did you do anything about inverses last year or the year before? Maybe last year? Yeah, a little bit. Okay. And the inverse function reverses the action of that function. So it's like the opposite of the function. So for example, it's like saying, it's not, well, there is a reflection that we can think of, but yeah, but we'll get to that in a sec. So if I think about composite functions, if I'm taking the inverse function and subbing it into the original function, it's going to give us x out. So let me think. So kind of keeping that in mind, you don't need to write this bit down in blue. Let's say I've got a function which is 2x, okay? What do you think the inverse would be to that? Not negative 2x? So half x, or x divided by 2, because so the inverse would be half x or x over 2. Because if I think about this, we wanted to produce the opposite effect, okay? So if I was to put this into this, I'm just going to get x out, okay? Now, kind of something that's important. So I'll write this. In order for a function to have an inverse, because not all functions do have inverses.
Do we write this part?
Yep, yeah, we can write this bit. In order for a function to have an inverse, it must be a 1-to-1 function. So i.e. it will have only one value of y for each corresponding value of x. And another way we can think about it is f of x will have a function, an inverse if it passes the horizontal line test.
So number 2 is not an inverse.
Okay, almost. So here we've got two functions. First off, are these both functions?
Yes.
Why?
Vertical.
They pass the vertical line test. Remember what we said? If it passes it once, it is a function, okay? So This graph only touches this dotted line once. So this is definitely a function, yep. What about this one? Is it a function? Yes, because it still passes the vertical line test. Okay, so these are both functions. Now, do they have inverses? Now, we said they have an inverse if they pass the horizontal line test. So does this pass the horizontal line test? Yes, because it only touches it once. So this definitely has an inverse. What about this? No, so this one does not have a function. Okay.
Does it pass it at the...
Technically, it passes it here, but we look at it as if it crosses anywhere. Okay, at 2 points. So we're going to say I'll draw my straight lines through both of these.
I said what because I thought you said the horizontal first and not vertical.
Okay.
But I
So as an inverse, as passes horizontal line test. It doesn't have an inverse as fields horizontal line test. Now, if we kind of think about why it fails, if I draw one more, let's draw. I want to go do some drumming. I hear them drumming outside.
Maybe that like all last week.
All right, so here we have the function x squared, okay? First off, is this a function? Because passes the vertical line test. Does it have an inverse? It's not a trick question. It does not because it fails the horizontal line test, okay? Now the actual, if I was, no, like actually you tell me, if I've got f of x equals x squared, what do you think? If this did have a function, what would it be? Root x, okay? Because it's like the opposite, okay? Remember, the inverse is the opposite of the function. Opposite of squaring something is the square root. And if I was to draw this, come on. If I was to draw root x, what it looks like is the following. Just change that. Root x looks like this. It goes like that and like that. Okay, so this is the graph of y equals root x. Now, is this a function? No, because it fails the vertical line test. So that's kind of why, even though we can algebraically work out what the inverse is, it doesn't necessarily mean that it is a function. The inverse is a function. I was like, what? So just to recap, so this is a function, and it doesn't have an inverse because it fails the horizontal line test, okay? But the reason it doesn't have a function is because, the reason it doesn't have an inverse is because if I assume that it does, this is not actually a function itself. That kind of make a little bit of sense. A little bit, okay. Well, let's find out how we figure out what are defined inverses. How to find an inverse. So it's a little method, and it's inside jokes. Thanks for making me feel left out.
No, see, I just put little from
Oh, did you see Rosie Rose today? You can't hit Rosie Rose though.
She was just in our team playing class. The entire time.
Okay, so the method here to find the inverse of this. Step 1. I always find it easier to do this by writing it as y equals. Now, you don't need to, but it's just, I think it's easier than writing out f of x. Okay, step 2. You're going to swap x and y. So when I swap x and y, I'm going to get x equals 3y minus 2 over 5. Step 3 is we rearrange for y. See, you're not writing this down, Sam. I know, but if you don't write it down, then if you get any of these wrong in future, I am going to come after you in the nicest possible way and remind you of this moment. All right, so we rearrange for y. So how do I rearrange this for y? Multiply both sides by 5, so I get 5x equals 3y minus 2. Then add 2, somebody else then. Divide by 3, so I get y equals 5x plus 2 divided by 3. So this requires you to be good at your algebraic skills. Step 4, and the one that everyone forgets, and it's the easiest one. Change. No, change y back to, or change y into, because we've worked out the inverse, so we need to write it as f inverse of x. And if you don't do that, you lose a mark. So this is the inverse of this. Yes, so let me see if I can find one which is like that. So let's see. Yeah, let's see. So find the inverse of f of x equals 3x plus 2 all over 2x plus 1. So we swap, and then we need to rearrange this now so it's y equals. And this is Safi's fault because she wanted to do one like this. If you need anyone to blame. All right, so we've got.
Layla got it right.
Okay, so first step, Layla.
So we're gonna take the 2y plus 1
Mm-hmm.
times it by both sides.
Okay, we're going to multiply both sides by 2y plus 1. Multiply by 2y plus 1. So I'm going to have x multiplied by 2y plus 1 on this side. And on this side, I'm going to have 3y plus 2. Next. That's the only thing we can do.
That's all you, Maya. And
I got it
doesn't it
incredibly
make
wrong.
sense?
2xy plus x.
Okay, expand the brackets, and thank you. 2xy or 2yx plus x equals 3y plus 2. Next. I want to get all my y's together. I want y equals. That's not getting all my y's on the one side. I want all my y's on the one side.
How are you gonna
Subtract 2yx.
Okay, I can subtract
Oh, I mean,
2yx.
divide by y, but then doesn't that?
If I divide by y, it's going to make it more difficult because I'm going to have x over y and 2 over y.
divide by?
I'm going to subtract 2yx from both sides. So when I do that, on the left-hand side, I'm left with x. And I've got 3y minus 2yx plus 2. Yes? Then, okay, let's subtract 2. I'm just going to write this up here so I can keep it all on the one page. So I get x minus 2 equals 3y minus 2yx. Now what? Divide by x. If I divide by x, then I'm going to end up with 3y over x. So that's going to make it more complicated. If in doubt, factorize. What can I take out as a common factor here? Y. And I end up with 3y minus 2x. Then to finish it off, divide by 3 minus 2x both sides. Does that make, isn't that just wonderful? Magical. And then our final step to get our last mark.
F minus 1.
Yep. Is equal to. That is a really common type of question. So thank you for asking, Safia. Ooh. I want to see an even horribler one. Horribler? Is horribler a word?
English was apparently
I was very good at English, I'll have you know. All good, Zuri? Okay, so this is another type that is really common. So, let's say if f of x equals, let's say, x squared plus 2x sorry, I'm just thinking to myself. So let's make it, sorry, let me just change, instead of plus 2x, let's make it plus 6x plus 1. So if f of x equals that, find the inverse. And I'm also going to say for this function, I'm going to give it a domain. I'm going to say that x is greater than or equal to where am I? Yeah. Thinking.
I don't want it.
Well, okay, well, why do we need the domain?
That's what I asked you.
Well, I'm asking you, I'm turning the question back on you.
It's like, why do we?
Why do we need it?
Yes, exactly.
Is this a function?
No, yes.
Yeah, what does it look like? It looks like a parabola, yeah? It looks like a smiley face. That is definitely a function. Does it have an inverse? No, because it fails a horizontal line test. So what I'm thinking is if I limit the domain in a certain way, then I can find the inverse. Sorry?
If it's like only positive, only negative.
Yeah, but I'm trying to think of what the domain would have to be. Okay, so we said y equals x squared, what was it, plus 6x? Plus 1? Okay, so it looks like that. And I am obviously not very smart because I picked the wrong thing. Where's a third? Negative third. Let's pick this. Okay, so I'm going to change the domain. Sorry. I'm going to say x is greater than or equal to negative 3. Okay, so all I'm going to be looking at is this part of the graph. Okay, only looking at this part. I'm going to ignore everything here. So if I'm only looking at this part, that means it is now going to pass the horizontal line test. Okay. Now in the questions, they would give you this. They would give you the right information, unlike me. So what did I say? X is greater than, less than I said. Less than or equal to negative 3. Okay, so our first step, we let our f of x equal y. So I've got y equals x squared plus 6x plus 1. Then I swap my x's and y's. So I'm going to say x equals y squared plus 6x plus 1, okay? Sorry, 6y plus 1. Okay, all good? Now I need to solve this for y. Not quite. Because if I do that, I'm going to have x minus 1 equals y squared plus 6y. Then what would you do?
I would take out y.
You would take out y, so you would do y. Then what would you do?
And then I would divide
You divide by
by y plus 6.
y plus 6, so you'd have x minus 1 over y plus 6 equals y. Multiplied by y. If I multiply by y, I'm going to have y times x minus 1 over y plus 6 equals y squared. No, because this is y plus 6, okay? So that is not going to help, okay? What exactly is this? It's a quadratic. How do you solve quadratics? Make it equal 0, right? So I'm going to take my x over to the other side. So I've got y squared plus 6y plus 1 minus x. So now I've got a quadratic. Yes, it's in terms of y, but that's no big deal. How do you go about solving quadratics? You can factorize or formula. And the formula for factorizing quadratics, so say your quadratic is ax squared plus bx plus c equals 0. The quadratic formula is x equals negative b plus or minus. That's my formula. Okay, now it just so happens it doesn't matter, okay, if it's x equals or x, this formula, this quadratic is in terms of x, this one is in terms of y, okay? So what is my a value going to be? 1, because it's 1y squared. What is my b value? 6, because it's whatever's in front of the other variable. What is the c value? Not just 1.
Oh, I mean, plus 1 minus...
1 minus x is my c value, okay? So a is 1 because it's 1y squared, b is 6 because it's 6y, and my c is the part that's left over. So I'm going to use my formula. This is probably the hardest type of these for this. So y equals negative b, so negative 6, plus or minus the square root of b squared, which is 36 minus 4 times a times c, which is 1 minus x, all divided by 2a. I'm just conscious we're going to run out of time, so I'm just going to go through this. So underneath the square root, I'm going to have 36 minus 4 times 1 minus x, 36 minus 4 plus 4x, that's 32 plus 4x. All over 2. This is now in terms of y. I've now got it so it's y equals. Yep. So all I need to do then is just say, all right, inverse is negative 6 minus the square root over 2. So that's probably the most difficult type, all right? Is when you've got the quadratic and you need to solve it like that, okay? I have seen that on exam questions for SL.
And how do you know if it's within minus or
Right, so we know that this one, x has to be less than negative, or equal to, x is less than or equal to negative 3. Now for this one, it's either going to be negative 6 plus the square root of all of this, or negative 6 minus it. And we will talk about that tomorrow, okay? Because that's more to do with the range, okay? So we will start on this next time. We're going to say, is the answer plus or negative? Okay, and it's to do with the domain and the range in this case.